Okay, we're going to look at simplifying expressions, and the super important thing about simplifying rational expressions is that they are factored first. It is so important that they are factored first, or you can't actually simplify them. So what I'm looking for is I'm looking for two brackets that are the same, one on the top and one on the bottom, and then I can simplify them. So if I look, this one will simplify with this, which leaves me with x plus 3, x minus 1, all over x minus 2. And then I need to state restrictions. What would make the function undefined? So it means what cannot x not be so that I don't divide by 0. So we always go back to the original question. So I'm going to say that x minus 2 cannot equal 0 or x cannot equal 2. And then I'm going to do x plus 10 cannot equal 0 or x cannot equal negative 10. And then I add that into my final statement that this is the answer to the question where x cannot equal 2 and x cannot equal negative 10. If I look at this next one, I'm looking for things that can simplify. So if I look at the binomial parts, this one will simplify with this one. While this looks similar to this, it is not the same, so they don't cancel out. And then I look at my monomial parts. So binomials simplify with binomials, monomials with monomials. So if I look, I have 25 and I have 10. They can both be divided by 5, so that will leave me with 5, and that will leave me with 2. If I look here, I have x squared and I have x cubed. They can both be divided by x squared. That doesn't leave me with anything. This one simplifies and cancels out completely, and this leaves me with 1x. On the top, I'm left with x minus 1 and x plus 5. And on the bottom, I'm also left with 5x plus 1. Now I need to look at what are my restrictions. So I have the monomial that has an x, so it will have a restriction. I have this binomial and this binomial. So I can say that 10x cubed cannot equal 0, x cubed cannot equal 0, or x cannot equal 0. I have 2x minus 3 cannot equal 0. So really it's the opposite of this divided by this. So it means that x cannot equal 3 over 2. Same thing with the last one. I have 5x plus 1 cannot equal 0. It's going to be the opposite of this divided by this. So x cannot equal minus 1/5. So that is my answer where x cannot equal 0, 3 over 2, and negative 1/5. Let's look at some more. These ones are not factored. So we absolutely need to factor them first before we can simplify them. They must be factored. So if I look, I have x squared plus 5x. I can take out an x. I'm left with x plus 5. If I divide this, I can pull out a 3, and I'm also left with x plus 5. Now that I've factored, that will simplify with that, and I'm left with x over 3. I go back and I look, what are the restrictions? There's a 3, but there's no x attached to it, so it doesn't create a restriction. I have x plus 5, and it's easier to use this version of the denominator than this one. These are the same denominator. This one is easier to use. So now I'm going to say, well, x plus 5 cannot equal 0, or x cannot equal minus 5. So that's my answer, such that x cannot equal negative 5. Again, we need to factor first before we're able to do the question. I'm going to factor over to the side just to save space. So I need to factor 2x squared plus 5x minus 3. So if I look, I have 2x squared plus 6x minus 1x minus 3. I can pull out a 2x, I'm left with x plus 3. I can pull out a negative, I'm left with x plus 3. I have x plus 3 and 2x minus 1. So this factors to x plus 3 and 2x minus 1. If I look at the bottom, this is a difference of squares. So this will factor to x minus 3 and x plus 3. So this will simplify with this, now that it's completely factored. And I'm left with 2x minus 1 over x minus 3. I need to state restrictions. So I look at my denominator. Again, it is much easier to use the factored form of the denominator. So I have x minus 3 cannot equal 0, or x cannot equal 3. And I have x plus 3 cannot equal 0, or x cannot equal minus 3. So there's my answer, such that x cannot equal, and we can say plus minus 3. Since they're both, we have two 3's, one's positive, one's negative, so you can state them separately, or you can say plus minus 3. If we look at this one is written in a different order than we normally see it in. So what I can do though, and this is also negative, and normally this won't be negative, so I can factor out a minus 1. And I'm left with 2x minus 1 in brackets. I need to factor 10x squared minus 7x plus 1. So I'm going to do it over to the side. So I'm looking for two numbers that work. So I'm going to get 10x squared minus 5x minus 2x plus 1. I can factor out a 5x. I'm left with 2x minus 1. I can factor out a minus 1. I'm left with 2x minus 1. And I have 2x minus 1, 5x minus 1. So the denominator becomes 2x minus 1 and 5x minus 1. So I can simplify this bracket with this bracket now that it's completely factored. So I'm left with minus 1 on top and 5x minus 1 on the bottom. Again, we look at the denominator for restrictions. The factored form of the denominator is much easier to use. So 2x minus 1 cannot be 0, or x cannot be equal to 1/2. And 5x minus 1 cannot equal 0, and x cannot equal, remember it's the opposite of this divided by this, 1/5. We say that x cannot equal 1/2, and x cannot equal 1/5. Last one. So if we look at this one, again, this is not written in the order we're used to writing it in, and I see that I can factor out a 2. So I'm going to factor out the minus 2 so that this one will become positive. And so I'm left with 4x minus 1 on top. And if I look at the bottom, I can factor out an x, and I'm left with 4x minus 1. While this may look like a difference of squares, it's not, it's just a common factor. So this will simplify with this, and I'm left with minus 2 over x. Again, we couldn't simplify till it was factored, and now I need to look at restrictions. So I need to look at the fact that x cannot be 0. Any monomial is x cannot be 0. And then I look at 4x minus 1 cannot be 0, or x cannot be equal to 1/4. So we say that x cannot be equal to 0. And then we can also just write a comma 1/4. So you can either state them individually like this, or you can just state them as a string with commas separating them.